Sometimes we are more interested in studying a quantified statement restricted to a subdomain A of D. In that case, we can introduce the proposition for all x in A, Px, which is defined as for all x, if x in A, then Px. Similarly, we introduce the proposition for some x in A, Px, which is defined as for some x, x in A, and Px. With these definitions, it is also straightforward to figure out what are their negations. For example, based on what we have discussed, the negation of for all x in A, Px, is the negation of for all x, if x is in A, then Px. By considering the compound statement as an entire quantity, this becomes for some x, not if x is in A, then Px. The latter becomes precisely x is in A and not Px. Thus, the negation reads for some x in A, not Px. And similarly, we see that the negation of for some x in A, Px becomes for all x in A, not Px. In other words, we should follow 3 steps. First, we keep the subdomain invariant. Second, we flip the quantifiers. Third, we negate the formula Px. And in this way, we will achieve the negation for these quantified propositions. Finally, keep in mind that when you change the subdomain, the quantified statements might have a different truth value. For example, let Px be the formula that x squared minus 2 is equal to 0. Let us look at the following 2 statements. The first one reads, the equation has some real solutions, which is clearly true as both square root 2 and negative square root 2 are real numbers that solve this equation. On the other hand, the second statement reads, the equation has some rational solutions, which is clearly false, since neither square root 2 nor negative square root 2 is rational. When we determine the truth value of a quantified statement, we should not only look at the quantifiers, we should also be careful what is the subdomain under discussion.